So, here we go. We got sixth period here, classwork, and today's work is logic implementation. I'm going to move it down here in order. So, logic implementation. Here's the PowerPoint. So, let's go over the PowerPoint. Let's open it with Google Slides, and we'll get this party started. Let's just wait for Google to do its magic. Google's not as fast as it once was. There we go. Too many people online. Present. AOI and OR's inverter logic implementation. So here we're taking a logic expression like this right here, and we're going to convert it into a logic circuit like this. There's two different ones, SOP and POS. So sum of products and product of sums. We will always use this one in class. However, today's assignment we'll do this one just to see how it looks, but we're never going to use it, and you can just wipe it out of your memory after we're done, unless you're going to be some sort of electrical engineer one day. Implement each midterm in the logic expression. So let's just get straight to the magic here. Here's an equation, and it's written in SOP, just to let you guys know. Okay, so stick that in your head. This is SOP. How do you know? Because it's the sum of products. Do you see this products right here? A times B times C times D. Those are ANDed together. These are ANDed together, and these are ANDed together, those products. And we're summing of those products. We sum them, in other words. But remember, we're not really adding or multiplying, correct? This is logic. These are ANDed together, ANDed together, ANDed together, and we have some ORs. But this is called SOP. This is the way it looks. You'll know POS when you see it. So this converts to this right here. Now, please note that they inverted the A, the B, the C, and the D. Why? Well, because there is an A that's inverted. Is there a B inverted anywhere? Oh, yes. At one point, you're going to need an inverted B. Will you ever need an inverted C? Yes, we need an inverted C, which means a not C. And a D? Yes, there's even a not D at one point. So that's why at one point or another, there's always an option to steal from the A here, or to take the A not, or the not A, I should say. So here you could take the B, or you could take the not B, depending whether you take it before or after the inverter. So that's why they have these options. Unfortunately, in this class, we will only have access to 2 inputs OR gates and 2 and 3 put AND gates, limiting your design. So what that means is this. Do you guys see this AND gate right here? That thing has 1, 2, 3, 4 inputs. So they cheated and they drew this with 1, 4 input, okay? They cheated and drew that with 1, 4 input, even though we in this class don't even have access to that. We don't have a 4 input AND gate. But here's a 3 input AND gate. See right here, they made it right there. And look at, there's 1, 2, 3 objects all ORed together, and they kind of cheated at the bottom here. Let's see if I can make this go away. There we go. If you look at that OR gate, it has 3 inputs. The very last gate at the bottom, it has 3 inputs. So really, it should look like this. And I'll explain this in a minute. So steps of designing. Here's a product of sums, a POS. This is what this looks like. The only difference is you'll have OR gates first and the AND at the end, and we'll go over both right now. So let's go ahead and do them for practice. I will do, we'll do this one right, where is it? This one right here. So we'll do this one, A, B, C, D, B, C, D. So we'll do that one together. So let's go ahead and get that started. Let me get my pen out. So we're going to say that F1 is equal to A, B, C, D. And A, B, C, D, B, C, D. Or, and I don't remember what the last one was because I have no memory. A, B. But very importantly, we cannot forget those inversions on top. That B was inverted. I did see that. And the D at the end, and the A and the C. So let's do those. The A and the C and the D at the end. Okay. So the A and the C are inverted and the D at the end. There we go. So we got to draw this, like the wiring diagram for this. It's quite easy. First off, First step, here we go, is you have to look at how many inputs we have. Oh my, we're gonna have 4 different letters. Okay, so A, B, C, and D. Okay, so I know I'm gonna have 4 inputs total. And if you were to do it in the worksheets, they'll tell you, hey, go ahead and do it with any amount of inputs. Let me show you what that looks like as far as the worksheet. Here we go. Go here. Here's the assignment for the day, and it says, here, do this assignment. In the space provided, draw an AOI circuit, which I'm about to do right now, that implements the logic expression F1, okay? For this implementation, you may assume that AND and OR gates are available with any number of inputs. So I'm going to do that too right now with any number of inputs. So let me show you how easy that is when you do it with any number of inputs. Here we go. A, B, C, D. So I have a not A. Remember, this is not A right here, right? I need a B. That's B. So this wire is B. I need a C. No, I need a not C. So this is a not C. And then a D. I need a D. And we're just going to take all of those and just go ahead and stick it, because it says I can assume any number of inputs. Here we go, a big old gigantic AND gate. Done. So this is now not A and B and not C and this one right here, which is the D, right? So this one's done right here. Now let's do this one. B, C, not D. B, so here's B, so let's put a little bubble. Remember, if you see a wire cross like that, these are not connected, but that is connected. That's why we put the bubble, so make sure you do that. Put a bubble when they're connected. So this wire is B, and then we have a C. Where is that? Oh, do not grab it here. Do not do that. Oh, there's C. No, it's not. That's a not, right? So let's undo that bubble. This is a C. And so this is C right here. And then a not D right here. Oh, we don't have a not D yet. So we're going to go here. We're going to bubble. And so this is not D because I put an inverter here. And there we go. Now we have the not D, the C, the B. There we go. And we're going to AND them together with a big AND gate with 3 inputs. Who cares, right? They said we're allowed to. B, C, and a not D. That's that one done. Now the A and the not B. Where's an A? Well, I got to go here to go to the A, because this is not A, so I got to go here to where the A is. So here's A, and I need a not B. There isn't one yet, so I'm going to go ahead and bubble and put an inverter. And this wire represents not B because it goes through an inverter, see, right here. And we're going to go ahead and put that into an AND gate, flat on the back, rounded in the front. And this is A and not B. Done. So anytime you stick letters into an AND gate, you just kind of multiply them together. That means they're ANDed together. Now we're done, but not really. We need to deal with these ORs. So it's this or this or this. And they said we're allowed to use any number. So I'm just going to stick them all into a big OR gate. Rounded in the back like this, like a moon crest, then pointy. And there we go. This wire now represents A, not B, this wire, or this one, or this one right here, A, B, C, D, just like this, or this wire right here, because this is an OR gate, right? B, C, not D. So we're done. This is the logic implementation, the wiring for this expression. That's it. Done. So technically, but notice I used 4 inputs, I used 2 inputs, I used a 3 input, I used a 3 input OR. So these AND gates, I used a 2, a 3, and a 4. But you're allowed to, because the worksheet says, for this implementation, you may assume that AND OR gates are available with any number of inputs. So go ahead and just draw it here. So draw this here. Then re-implement the circuit, assuming that only two input AND gates, 74LS08, that's the exact number, the model number of this two input AND gates, and two input OR gates, the 74LS32, that happens to be the number for these type of OR gates, and inverters, which are 74LS04s, are available. So now the inputs can only be twos. So let me do that. Let's redo this where they're only twos. How long will this take? How fast can I click? Here we go. Almost done. I'm doing 10 clicks per second. Is that fast? I don't know. There's a website that can test that. So here we go. Pretty much I'm done at this point. All right. So now we only have two input ANDs and two input ORs. So here we go. No big deal. Let's do this one first. So we're going to need this not A still, okay? And we need a B. Now, I only have two inputs, so watch this. I have to AND them together already. What is this wire? It's not A, and this is B. I did these two, but I need to still add those C and D's together. So let me do that. I need a not C. This is a not C. And I need a D. Put that together. And this is a not C. And this wire is a D. Done. But now I need to put them together. I need to AND these two together with these two. So let's do that. So you see how it's an extra step or two? I can't just jab them all into one OR gate. One AND gate. So what is this wire right here? This wire is not A and B. And this wire is not C and D. And remember, whenever you put them in an AND gate like this, this, or this, all you do is put the two letters and push them together. This letter, push them together. These letters and these letters, push them together. That just means they're ANDed together. I'm using AND gates, but I have to do two at a time only. Okay? This is not the only way to do it. There's other ways to do it. Okay? So if you chose this way, let me just show you real quick. I'm going to erase this in a second. But let's say you did this. Let's say you need to make A, B, and C and D, right? So you need to make this. Pretend you have to do this right here, A, B, C, D. You could do this, so you can put an AND gate and go A, B, and you could put an AND gate and put C and D. Then you can put this, and you'll have A, B, C, and D, right? A, B, C, D. Put them together. So that's one way to do it. But that's not the only way. So, come on, I need more. There we go. That's not the only way to do it. There's other ways. Here's one right here. You could go A and B, and then you could put in the C one at a time now. See? A, B, this wire, and C. And then add one more and go A, B, C, and this wire, which is the D. Both require the same amount of gates, so it doesn't matter how you do it. So if you want to put these together and these together and then those together, or like this, one at a time like I did, it doesn't really matter, to be honest with you. It's the same thing, all right? Alrighty, here we go. So I did this one. Now let's do B, C, not D. So let's see, I'm going to take the B. This is B. I need the C, not here. That's C, not. It's not C, right? So let's go here, C. And there, I already have two. So remember I can only do two at a time. So let's just AND those together. I'm going to get a B. That's this wire right here, B, and not C. And it doesn't matter which order. I would just do alphabetical every single time, but it doesn't matter which order. This and this is the same as the other way around. Just put them in alphabetical order. And then what else did we have to do? Oh, did I mess up? I put a not. I messed up because I did the C. Wait, no. I did B and C together. I didn't have a not. Huh. There we go. So this is just a C. This is a C and a B. That's it. Okay. And then I need the not D, which I don't have yet, so I'm going to go ahead and poke it here, and then run a wire, and then put the inverter. Now it's not D. And now when I AND these together with an AND gate, it's B and C right here with the not D. Okay, so done. And then I need this one, A and not B. So where's the A? It's over here, not here. That's a not A. So here's A. And let's go with B. But we're going to have to invert the B, because I need that inverted B, right? And then we could go ahead and stick these in an AND gate. And we get A. Remember, this is A. And not B. So I did this one now. So I have 3 wires. I have this one, and this one. This, and this. But I need to OR them together, right? That's what plus signs are, ORs. So let's just get going. But we can only use 2 inputs this time. So let me erase this, by the way. That was from that sample problem I was doing. A little side problem here. So let's put these 2 together. And we're going to put an arced back and a pointy front. And that's an OR gate. And we just say this or this. That's what it means. Doesn't matter which one's first. A, B, C, D. That's this wire. Or this one. And then we could OR this one. Remember, because we could only do 2 at a time now, because that's what they said. They said pretend you only have 2s available. And we're done. I don't have room to write it, but pretty much you're just going to rewrite all this and then put a plus sign and put that right here. So pretty much that's that equation right there. And we're all done. That's all there is to it. In fact, you know what, guys? I'm going to make your assignment easier. If you're paying attention to this, this is going to be much easier. So watch this. So you're going to do this problem right here, and you're going to draw it, and you could assume that you could stick all 3 of those in one AND gate. Great. Then right here, pretend like you can't, and you only have 2 inputs, okay? Then using computer design software, enter and test the logic circuit you designed. So in other words, build it in Multisim, and then you have a screenshot of it here. Using a digital logic board, that means you build it on a breadboard. We're not going to do that just yet because you don't have those AND gates and OR gates yet, so we're going to skip this. You don't have to do 4. And this one right here, skip it. This is a product of sums. We're never going to do product of sums in this class. Just don't even worry about it. Skip this, skip this, skip this, skip this, and skip this. And just go down to the conclusion and do this one, the conclusion. And shown below are 2 equivalents. Don't even worry about this because they're comparing SOP versus POS. But we're not doing POS, so don't even worry about that. You can skip this conclusion. And then it says, first analyze the SOP version. Yeah, but that's all part of that same one. So you can skip the rest of this. So pretty much, this is much easier than you might have thought. All you have to do is do number 1 for the conclusion. Skip this one, this whole thing right here. Skip all of that and just do 1. So the very beginning of the worksheet, just do 1, 2, and 3. Okay? Then come all the way down to the conclusion and do 1. That's it. Okay? And nothing more than that.